Good day. How are you doing today? So in this lesson, I'm going to show you how to differentiate quotients. So we are going to use what is called the quotient rule, and the quotient rule is applicable to fractions. So let's say if you are given y is equal to u over v, where u is equal to the function of x, and also v is equal to the function of x, then the derivative of this function will be dy dx is equal to v du dx minus u dv dx, all divided by v squared. So here it matters that your denominator is the v. So do not swap them around. Make sure that your denominator, you let it v and u squared at the end. You always start v du dx minus u dv dx. So here order matters. So it's not like the product rule. The product rule, you can swap them around. A v can be a u, but in here, your v, it's always the denominator. Okay, let's get into some examples. So in this example 1, we are asked to use the quotient rule to find the derivative when y is equal to x cubed over x squared plus 3. Remember, this is a quotient. So what we do first, we let v is equal to x squared plus 3, and our u is equal to x cubed. Remember, our v is always the denominator, and your u is the numerator. Then you derive the v function, dv dx, that will be equal to 2x, and you find the derivative of u, which is du dx, will be equal to 3x squared. And remember, for the quotient rule, dy dx is equal to v du dx minus u dv dx divided by v squared. So then you just do some simple substitution. Your v is just x squared plus 3, and your du dx is just 3x squared minus your u is x cubed, and the dv dx is just here, which is the 2x. So times 2x, all divided by x squared plus 3 squared. And this can be simplified further to be 3x to the power 4 plus 9x to the power 2 minus 2x to the power 4, then divided by x squared plus 3 to the power 2, which can be further simplified because we've got like terms here, and that becomes x to the power 4 plus 9x squared divided by x squared plus 3 to the power 2. And this can be further simplified by factoring out x squared, and that becomes x squared plus 9 bracket over x squared plus 3 to the power 2. And that's how you differentiate this quotient. In the next example, you're asked to use again the quotient rule to determine dy dx. So in this case, remember again, your v is equal to 4x plus 3, and your u is equal to 3x squared plus 2. Then we derive the v, dv dx will be equal to 4, and here we derive the u, du dx will be equal to 6x. And remember, for quotient rule, dy dx is equal to v du dx minus u dv dx, all divided by v squared. Then we just do some simple substitution. So remember, our v here is 4x plus 3, bracket, multiplied by du dx, which is 6x, minus u, which is 3x squared plus 2, bracket, times dv dx, which is times 4, all divided by 4x plus 3, bracket squared. And this can be further simplified to be 24x squared plus 18x minus 12x squared minus 8, all divided by 4x plus 3 to the power 2. And this can be further written as 12x squared plus 18x minus 8, all divided by 4x plus 3 to the power 2. Yeah, I'm comfortable to leave it here. In the next example, example number 3, we are asked again to use the quotient rule. So we do the same. V is equal to 2x squared plus a 3, and our u is equal to x cubed plus 7, and dv dx will be equal to 4x, and du dx is equal to 3x squared. Then remember the quotient rule, dy dx is equal to v du dx minus u dv dx, all divided by v squared. And then we just do some simple substitution again. And v is 2x squared plus a 3 multiplied by du dx, which is 3x squared, minus u, which is x cubed plus 7, multiplied by dv dx, which is a 4x, then all divided by 2x squared plus 3, then squared. Then this can be further simplified to become 6x to the power 4 plus 9x squared minus 4x to the power 4 minus 28x, all over 2x squared plus 3 squared. And this can be rewritten as 2x to the power 4 plus 9x squared minus 28x, all over 2x squared plus 3 bracket to the power 2. Yeah, you can actually factor out the x on top and you can simplify it further. Okay, moving on to the last example. Find the equation of the normal to the curve. Y is equal to that at the point 2, 4. So remember now, to do the equation of the normal, we need to find first of all the gradient of the tangent. Then when we get the gradient of the tangent, remember the gradient of a tangent times the gradient of a normal must be equal to minus 1. Then we can determine the equation of the normal. So we need to first of all differentiate this function. So this is a quotient rule again. So we say u is equal to 3x squared and v is equal to 2x minus 1. And derive u, du dx is equal to 6x and dv dx is equal to 2. Then remember, dy dx with quotient rule is equal to v du dx minus u dv dx, all divided by v squared. Then we just do some simple substitution, and our v it's 2x minus 1 in a bracket times du dx, which is 6x minus u, your u is 3x squared, multiplied by dv dx, in this case it's a 2, then divide by the v squared, and v squared is just 2x minus 1 bracket squared. And this can further be simplified to become 12x squared minus 6x minus 6x squared, all divided by 2x minus 1 bracket squared, which can be further simplified to become 6x squared minus 6x divided by 2x minus 1, all to the power 2. Yeah, we can leave it here, or we can factor out 6x on top, and then you write down the final answer. Now, to do the gradient, so we have got now our dy dx. Then we substitute the x value to get the gradient of the tangent. So the gradient of the tangent mt will be equal to 6 in a bracket. We substitute for 2 for x into this function here. Then that will be 2 squared in a bracket minus 6 multiplied by 2 divided by 2x minus 1 bracket to the power 2. Actually, for x here, it's a 2 as well. So then that gives us, that's a 424 minus 12 divided by, that's a 3 squared, that's a 9. So, and then this will give us a 12 over 9, which is actually 4 over 3. That is the gradient of the tangent. So the gradient of the normal will be an inverse of that one times a negative 1. So that will be negative 3 over 4. So we have now the gradient of the normal. So remember, the normal crosses this point. So now we can calculate, we can determine the equation of the normal using the equation of a straight line. Y is equal to mx plus c. And we can, now we know our m, we just need to find the c. So we substitute the coordinates of y, that will be 4 is equal to, and the m is negative 3 over 4, multiplied by a 2, then plus a c. Then we get our c value. So c is equal to, in this case, that will be a 4 minus 3 over 2. 4 minus 3 over 2. 4 minus 3 over 2. That will be 4 minus 3 over 2. Let me just use a calculator for that. So 4 minus 3 over 2. That gives us about 2.5, which is 5 over 2. So our c is 5 over 2. So then the final equation will be y is equal to negative 3 over 4x plus 5 over 2. Actually, it's not a minus here because it's going to be adding. So that is 4 plus. So that is actually 11 over 2. So the c value is 11 over 2. So that will be 11 over 2. So that is the equation of the tangent. And that's how you do your quotient rule. Let me know if you've got any questions. Hope to see you in the next lesson.